All right, what I want us to do next is we're going to discover a formula that we need to find the interior sum of no matter what polygon they give you. So we're going to start with the one to three sides. We've worked with a triangle before. We know what a triangle looks like. All the angles within a triangle always add up to what? Good, to 180. So I know that if I have a triangle, it's always going to add up to 180. So what I'm going to do is I'm going to make triangles in all of my shapes. Okay, so I know that all of these angles inside, and this is called interior. Okay, interior. And again, let's go back to our vocabulary page. All right, where it says polygon. All right, what is a polygon? A polygon is a closed figure with at least 3 sides. So, is this a polygon? No. Why not? Because it's not closed. All right. Is this a polygon? Yes. Why? Because it's closed and it's made of at least 3 sides. So this has 1, 2, 3, 4. So a polygon is a closed figure with at least 3 sides. So if it's not closed, it's not a polygon. If it doesn't have at least 3 sides, it is not a polygon. All right, so back to what we're talking about right here, which is we're going to figure out what the interior sum of all of these polygons are. All right, let's go with the word interior. All right, interior. You should remember what this means. This means what? Inside. Okay. So I'm sorry. So I'm going to write that here. Interior. Inside. All right. Now I said I want to know the interior sum. Now what does the word sum mean? Sum is when you add everything together. So when you add everything together. All right, so if I wanted to find out the interior sum, it's when I add everything inside together. So interior sum is when I add everything inside together. All right, so let's take a look at the first one, a triangle. You already know the interior sum of a triangle because you know when you add everything together inside, what are you always going to get? 180, okay, because that is a triangle. So what we're going to do is you're going to take a ruler and we're going to make triangles within all our other shapes in order to find out what the interior sum is, which means when we add everything together, what are we going to get? So the way we're going to do this is quite simple. We're going to go to the vertex of each shape, any vertex. And again, I don't want to assume anything, so let's go back to our vocab. We've got a new word, vertex. All right, vertex is a point where 2 lines meet. All right, vertex is a point where 2 lines meet. In other words, here's the line, here's the line. Where they meet, that point right there is the vertex. All right, even if I had a triangle, where these 2 lines meet, that point right there is a vertex. Where these 2 lines meet, that point right there is a vertex. So just where 2 lines meet, that's a vertex. All right, so we're going to draw. Now, you can pick, you don't have to pick the one I picked. You can pick anywhere because remember, a vertex is where 2 lines meet. Okay, so these are all vertex. Now, you're going to draw lines from one vertex to the other, but only starting from one. Okay, so I'm going to start from this side. From here, I'm going to draw to every vertex, every other vertex. So you see that it goes there. That line is already there. From the same vertex, you're going to draw it to every single vertex. You see there's a new line there. And the last one, there's a vertex right there. Okay. Same with here. Here's a vertex. Here are all the vertex. All right. Pick one. Doesn't matter. I'll pick this one right here. From this point, join up every vertex. So there's one. From this point to the next vertex. from this point to the next vertex, from this point to the next vertex. Alright, so basically you start from one vertex and you just keep joining to all. So here are the vertices. The vertices, by the way, is plural for vertex. Again, pick one. I'll start at the bottom. From this vertex to that one, there's already a line. From this one to that one. From here to there. All I'm doing is drawing lines from one vertex to every other vertex on the on the shape. All right, there we go. All right, and you can see what I'm doing. As I'm doing this, I am making triangles. Okay, so after you finish drawing your lines from one vertex to every other vertex. All right, vertex there. Vertex there. Alright, and obviously I'm going to stop drawing the ones that are already drawn in, but just let you know they are there. Alright, same thing here. Here are all my vertices where two lines meet. These are all my points, and you're going to draw your vertex from one to every single one. And it doesn't matter which one you start with, as long as you start with that same one over and over again. Alright, and you're going to do the same thing for the back. Again, all the vertices. All right, all the vertices. Alright, and the last one. One. Alright, perfect. Alright, so I've got lines joining from one vertex to every vertex of the other one. Alright, now what we're going to do is we're going to count. Alright, you're going to notice that each time we've got those lines, what I've really done is I've made triangles. Like you see that this is a triangle and this is another triangle. Here's a triangle, here's another triangle, here's another triangle. By joining the vertex, I have made triangles. Well, here's some common sense. If I know that every triangle adds up to 180, right? I know that every triangle adds up to 180. What is all of this going to add up? How many degrees is going to be total? Okay, well, what you have to do is obviously each triangle is going to add up to 180. So this plus this plus this is going to give me 180. Well, here's another triangle. That means this plus this plus this is also going to give me another 180. So what is the total interior sum? Okay, so when I add up all these angles, what am I going to get? Well, I have 180 plus 180. So 4 sides, the interior sum is going to be 360 degrees. And the same thing here. How many triangles do you have? Well, I have 3 triangles. Each triangle is 180, so here I have 180 plus another 180 plus another 180. Or you could just do it a little faster. If one is 180 and you have 3 of them, 3 times 180, okay? And that will give you the interior sum of a 5-sided shape, which will be 540, okay? So this would be 180 plus 180 plus 180, or 180 times 3, which is going to be five sides is going to be 540 degrees. All right. Now you're kind of getting the idea of it. What is the interior sum when you add up all the angles of a 6-sided shape? Well, you need to figure out how many triangles you have by, again, from one vertex to all the vertices. And this one I have 1, 2, 3, 4 triangles. So if I have 4 triangles, 4 times, and each triangle is 180, this 6-sided is going to be 720. All right, so what I want you to do is go ahead and finish the rest of them. Tell me how many sides, what is the interior sum of a 7-sided figure, of an 8-sided figure, and then do the back. All right, so 7 sides. How many triangles does 7 sides have? 1, 2, 3, 4, 5. That's 5 times 180. All right, so 5 times 180. The interior sum is 900 degrees. On the 8 sides, it has how many triangles? 1, 2, 3, 4, 5, 6. All right, 6 times 180 is 1080 degrees. The interior sum is 1080. All right, on the back page, all right, 9 sides. How many triangles does 9 sides have? Go ahead and count them. 1, 2, 3, 4, 5, 6, 7. So I have 7 times 180. All right, so 7 times 180. And so the interior sum of 9 sides of a nonagon, is going to be 1260. 10 sides, how many triangles? 1, 2, 3, 4, 5, 6, 7, 8. 8 triangles, so 8 times 180. 8 times 180 equals 1440. All right, 12 sides. Now, by now, you know, polygons go on forever. You can have a 13-sided polygon. You can have a 14-sided. You can have a 100-sided polygon. All right. Instead of drawing a polygon every time and doing the triangles, there's a relationship between the number of sides and the number of triangles. So, for example, here we saw we had 10 sides. How many triangles did we have? 8. Here we saw we had 9 sides. How many triangles did we have? 7. Okay, here we have 12 sides. I'm just going to make an assumption. I think they're going to be 10 triangles. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 triangles. So 10 times 180 is going to give me 1800 degrees. All right, so the relationship between the number of sides and the number of triangles is it's always 2 triangles less than the sides. So if I said, for example, a 50gon, I want to know, okay, what is the interior sum of a 50gon? Well, remember you count how many triangles there are. So if there are 50 sides, the number of triangles is always going to be 2 less than that. So there are really 48 triangles. And each triangle is 180 degrees. So the interior sum is going to be 48 times 180, which is 8640. Okay. So again, it's quite simple. The number of sides, the relationship of the number of sides, the number of triangles is always going to be 2 less triangles than the side. Let me just double check the rest of this so I can make sure that we are completely correct. This is a 4 sides. All right, 4 sides, and I said a triangle. It's all the relationship between sides and the number of triangles is always going to be 2 less. So if it's 4 sides, there's 2 less triangles, so it's only 2 triangles. So 2 times 180 is 360. Same thing with the 5 sides. If it's 5 sides, there are 2 less triangles than the sides. So 5 minus 2 is going to give me 3. So there are 3 triangles, and 3 times 180. 1, 2, 3 times 180. 6 sides, so that means there are 4 triangles because they're 2 less than the number of sides. 4 triangles, see, 1, 2, 3, 4. 4 times 180, 720. 7 sides, 2 less than 7, which is 5. 1, 2, 3, 4, 5. 5 times 180, which is 900. All right, 8 sides. So 8 minus 2 is 6 triangles. 1, 2, 3, 4, 5, 6. 6 times the 180 triangle is 1080. So it is quite important to know the relationships between the number of sides and the number of triangles, because you're not going to be able to draw, you know, the polygon that each question is going to talking about, especially when it comes to like, you know, 100 sides. So you're not going to sit here and try and draw 100 sides so you can figure out how many triangles are in it. All right, so let's actually do that one. So say it was 100 gone, and the interior sum of 100 gone. Okay, remember, if it's 100 sides, there are 2 less triangles. So if it's 100, there are 2 less, so that means that there are 98 triangles. 98 times 180, and that's going to give you 98 times 180, 17,640 degrees. Okay, so the interior sum, okay, when you add up all the angles all the way around for each of this shape, the interior sum is what we've been finding out. So actually what we're going to do is we're going to come back to this page right here, and we're going to go to write down the title. This is interior sum. So the inside, when you add up all the angles, the inside, the interior sum is the title. Interior sum of polygons. Okay. Now I'm going to use what we just found out to write a formula, and if you're lucky, they'll give you this formula in your EOC. But even if they don't, you now know how to do it. All right, there's a formula to say this, because remember, every time we took however many sides there were, right, we subtracted 2, and that's going to give us the number of triangles. Then we multiplied that by 180. So the interior sum is always equal to the number of sides. So let's just say n for the number of sides, minus 2, because that's going to give us how many triangles it is. And then we're going to take that and multiply it by 180. And that's going to give us this. So if you remember this formula, you don't have to draw it. Or if you just remember however many sides, take away 2, multiply that by 180, because that's how many triangles, and that will give you the interior sum. So this is the interior sum formula. Okay. So it doesn't matter however many shapes they tell you. So if they tell you 100, 100 minus 2 is 98. 98 times 180 is 17,640. So the interior sum is 17,640. If they give you 12 sides, 12 sides minus 2 is 10. 10 times 180 is 1,800. So again, the interior sum is the number of sides minus 2. That's going to give you the number of triangles multiplied by 180, because each triangle is 180. And that's how you do the interior sum.